All right, good evening, everybody. Today we're going to do a practice and problem solving. I'm going to go ahead and do the even ones today since we're starting with number 6. So let's begin. Find the quotient for 5 over 7 divided by negative 11 over 5. That says to fill in the boxes to find the quotient. We can remember that we can find the quotient by always remembering that the second fraction, when we're dividing, has to be turned upside down, and then we can multiply it to find our answer. So in this case, they're asking us 5 over 7 divided by negative 11 over 5 equals, well, that's going to be 5 over 7 times. Remember, we turn this second one around, so it will be negative 5 over 11. And now we can treat it like a multiplication problem. 5 times 5, the top number, multiplied to the top number. And that's going to be, well, they've already said this is negative, so we don't need to put the negative sign there. But 5 times 5 is 25. And 7 times 11 is 77. I don't believe you can simplify that, so that's it, 25 over 77. 7 is yours to do. Let's go to number 8. Which multiplication expression is equivalent to the division expression negative 7 over 17 divided by 13 over 34? Once again, let's remember, we take the same numbers, we're just going to take the second number and flip it upside down. So let's see if A applies. Well, in this one, they took the first number, fraction, and they flipped it upside down. So that's not right. On B, they kept the first one the same, and they kept the second one the same and multiplied, and that's not correct either. On C, they flipped the first one again. Automatically, we know that's not right. And on D, it says they kept the first one the same, and they flipped the second one. That's exactly what we're looking for, and then they multiplied. D is going to be our answer for number 8. All right, and let's move on to number 10. All right, we're on number 10 now, and it says the water level of a lake fell by 1 1/2 inch during a 1 2/3 week long dry spell. Simplify the complex fraction below to find the average rate at which the water level changed every week. Over here they show that they have negative 1 1/2 over 1 2/3 inches per week. So if we're going to find the average rate, we need to go to remember that every fraction is a division problem. We have a division problem, though, in a division problem. Whenever we have a fraction in a fraction, we know we're using KFC. And that stands for keep, flip, and change. Some of you might have learned it as KCF. Keep, change, flip. Whichever one you want to use, that's fine with me. I always use KFC because it's easier to remember with good old Kentucky Fried Chicken. So we're going to keep the first fraction the same. We're going to flip the second fraction. And we're changing from division to multiplication. All right, let's try it. In this case, we see that we're going to have 1, negative 1, and 1/2. And we're going to be dividing that, because every fraction is a division problem, by 1 2/3. Well, first of all, we have to remember that we're going to flip, keep, change, flip, means it's going to be but before we can flip it, we have to change these into improper fractions. All right, so this is going to be 2 times 1 That's 2, and 2 plus 1 is 3. So this is actually going to be negative 3 over 2 that we're dividing by. 3 plus, times 1 is 3, plus 2 is 5. So this is going to be 5 over 3. And now we can use our keep, flip, change. We're keeping the first fraction the same, which would be negative 3 over 2. And this time we're changing to multiplication, right? And we're flipping that second one, so it's going to be 3 over 5. Now we're ready to go ahead and solve. We simply multiply the top number to the top number and the bottom number to the bottom number. 3 times 3 is 9. 2 times 5 is 10. And since we have a negative times a positive, we know our answer is negative. Our answer is negative 9 over 10. All right, let's move on to number 10, or number 12, excuse me. It says find the reciprocal. Let's see, the reciprocal of negative 1 and 1 over 17. Well, first we have to turn that into an improper fraction. 17 times 1 is 17. 17 plus 1 is 18. So this is going to be equal to negative 18 over 17. But remember, they're saying they want the reciprocal. The reciprocal means we're going to turn this upside down. So the reciprocal will be negative 17 over 18. Okay? And why is that the reciprocal, you might add? Well, it's because any number that I can multiply to the number that I have that will equal 1 is my reciprocal. Okay? So we can see that if I multiply this, I'd be using the butterfly method to get rid of both my numerator and denominator and leaving negative 1 times negative 1, which equals a positive 1. It says find the reciprocal now of negative 17 over 18. Hey, that's the number that we had. Well, it should be no surprise then that that is going to be negative 18 over 17. And of course, that's an improper fraction that we can turn into negative 1 and 1/17. And that should be no secret because that's what we started with, right? So that would be the reciprocal there. Now it says, explain why the answer for part A is the multiplicative inverse of the answer for part B. Well, multiplicative inverse means, again, that I can multiply them together and get 1. So I'm simply going to put see, they can be, better yet, the product of A and B is 1. Okay, that's why. All right, we're off to number 14 now. All right, we've got a two-part question here where it talks about a water tank in Stuart's home has a small, steady leak. According to the picture, it says the loss of 1 3/5 milliliter in 10 minutes. Use a complex fraction to represent the change in the volume of water in 1 minute. Okay? So let's see. Well, first of all, we have to go ahead and fill in that blank, and that should be easy enough. we know since it says a loss of 1 3/5 milliliter, a loss means that this number is going to be a negative because we're losing. So let's see, this is going to be a negative 1 3/5 over 10 minutes. Now it says simplify the complex fraction to find the change in the volume of water in the tank in 1 minute. Okay, so if we're going to be doing this, we're dividing this by this. Once again, we have a complex fraction because anytime we have a fraction in a fraction, we have to use our KFC method. And again, if you want to call it KCF, fine. That's all up to you. Let's try it. First of all, we have negative 1 3/5. And we're going to be dividing that by 10. And we could turn 10 into a fraction by putting it 10 over 1. Now we have to turn this into a complex fraction. So this is going to be equal to, let's see, 5 times 1 is 5, plus 3 is 8. So this would be negative 8 over 5 divided by 10 over 1. And now we'll use our KFC method. We keep the first one the same, negative 8 over 5. We're going to flip the second one, so it's going to be 1 over 10. And we're going to change from division to multiplication. We could use the butterfly method and see that we have 8 and 10 here. So we could turn this into, let's see, both of them are divisible by 2. So we could turn this to 5, and we can turn this to 4. Now we have 4 times 1, that equals 4. We have 5 times 5, which equals 25. And we have a negative times a positive, so we know our answer is negative. So the answer to this problem is negative 4 over 25. And I think we're ready to move on to number 16, high order thinking. Now this one is going to take a little bit of deductive reasoning here because we're talking about time and it's talking about each hour. But the time they give us isn't given to us in an even amount of hours. So you can see that it says between 10 p.m. and 7:45 a.m. The water level in a swimming pool decreased by 13 over 16 inches. So if we're talking about time here, they're saying assuming that the water level decreased at a constant rate, how much did it drop each hour? So they're asking us how much did it drop in every hour. The water level decreased by how much each hour. So let's see, first of all, we know that it decreased by 13 over 16 inch. Okay, and we have to put time on the bottom. Let's see, and since we can't put it in hours, what we're going to put it in, let's see, 7:45, we could put it in quarter hours. So first, let's see how many hours there are. From 10 to 7, well, 10 goes to 11, 12, right, to 12 o'clock, and then 7 more hours, that'll make 9 hours. We have to take 9 times 4, because there's, we're talking about quarter hours, so we have to multiply that by 4. That's going to give us 36. All right? So in other words, in increments of 15 minutes, there's 36 increments of 15 minutes and 9 hours. Now we have to add 45 minutes, so it's another 3, let's see, 15, 30, 45, that'll be 3 more increments of 15 minutes. So we're going to add 3 now, and that's going to give us a total of 39, 39 quarter hours, okay? 39, okay, we're just going to put quarter hours, okay? And now we have our two numbers that we can work with. Again, this is a division, a complex fraction, because we have a fraction in a fraction. This is really 13 over 16 that we're dividing by 39 over 1. Now we use the KFC method. That's going to be 13 over 16. Keep the first one the same. We're changing the multiplication, and now we'll turn this to 1 over 39. And now we have, well, we could use the butterfly method here, 13 and 39. I know that 13 goes into 39 3 times, so we can slice that off. Put a 3 there, and cut through that and put a 1 there. And now we have 1 times 1, and that equals 1. And 16 times 3, let's see, 16 times 3, I think it's going to be 48. 18, carry the 1, yep, 48. Okay, so that's 1 over 48. And now we have to multiply this. Remember, they want to know how many hours are in here. We know there's 1 in 48 quarter hours, but now to find out how much it would drop each hour, we have to multiply this by 4. Okay? And so that's going to be 4 over 48. Again, we can use the butterfly method and put a 1 there. And that would put a 12 down here. And that's going to give us 1 over 12. So, in essence, it's saying that the water level decreased by 1/12 inch. Okay, each hour. That's our answer. Let's see, 17 is yours to do, so good luck, and I'll see you in your class.